Welcome to the Daily Integral series, where we do integral problems. In this first example, we can use the antiderivative technique. And so basically, you add 1 to your previous exponent, and you divide by the new exponent that you have. So it's going to be 3x to the third over 3 plus 2x to the second over 2 plus x, and then plus c since it's an indefinite integral. So then you want to go x to the third plus, x squared, and then plus x plus c. So that's going to be the first one. So the second one, you can see the integral of e to this 2x sine x dx. So the first thing that should come to mind is that you have two different functions, and so you want to utilize the integration by parts. And so the best way to utilize that is set u to sine x and dv to e to the 2x. And so when you get du, so the derivative of sine x is going to be cosine x. And then there's a certain technique for e's, so it's going to be 1/2 e to the 2x. So now we can utilize the integration by parts formula, which is u times v first. So we can do sine x 1/2 e to the 2x minus the integral of, let me just add a dx because that was supposed to be there. So 1/2 e to the 2x cosine x dx. And so there's another integration by parts. So you need to do cosine x for the u, and then dv is going to be 1/2 e to the 2x. du is going to be negative sine x because the derivative of cosine is negative sine. And then v is going to be 1/4 e to the 2x. So now you just have to put it back in. So 1/2 e to the 2x sine x alongside adding u and v again, so cosine, let's just do 1/4 first so that makes it easier. So 1/4 e, what is happening? E to the 2x cosine x, and then minus the integral of negative sine. Let me just do the same thing here. Let me just utilize the 1/4 first, and then negative sine x dx. So this transfer of this negative here is going to go out, and so that's going to change the portion of it. So it's going to be 1/2 e to the 2x sine x minus 1/4 e to the 2x cosine x. And so we can also take out a 1/4 as well. So we're also taking that out of the process. So e to the 2x sine x. And so now what we can do is, this is kind of the portion where we have an I, and so we have to go for 5/4. I is equal to 1/2 sine x to the e 2x minus 1/4 cosine x e to the 2x. And so now I would be 4 over 5 of 1/2 sine x e to the 2x minus 1/4 cosine x e to the 2x. And so that would be the unsimplified version. The next one is going to be x over x squared plus 1. So this one we can just use U-Substitution. So U-Substitution would be set u to x squared plus 1 du. It's going to be 2x dx because anything within a constant is just going to be 0 in terms of the derivative. So, and then we can set dx equal to du over 2x. And so when we go back to the integral, x over u, and then we multiply du, and then 2x. So then we have 1/2 since the u's cancel. Oh no, sorry, the x's cancel. So then we have du over u. But we can just say 1/2 1 over u du. That just makes it easier. So then 1/2 ln of u plus c, and now we can sub u back in. So u is going to be x squared plus 1 plus c. So this next problem, we have natural log of x dx. So for this one, we really need to see there's still going to be these two functions. So u, and then there's going to be dv. So u is going to be ln x, and then dv is going to be 1, and then v would be x, and du would be 1 over x. So this one isn't as tricky as the previous integration by parts. So we just have to do u times v. So x times ln x is equal, oh no, sorry, not equal, minus the integral of 1 over x times x, which would get you down to the integral of basically 1 at that point. So x ln x would be minus x plus c. And no, I didn't forget. Okay. So that would be the answer to that question there. So let's wrap things up with this last question. 1 over x squared plus 4x plus 5 dx. So the strategy to use for this one is going to be completing the square. So originally you have x squared plus 4x plus 5. You want to complete the square, so half of 4 is 2. Squared is still 4. So coincidentally, you're still left with 5. So x squared plus 4x plus 5. And then you can complete the square by doing x plus 2 squared plus 1. So when you plug this back in, when you have 1 over x plus 2 squared plus 1 dx, you now have to do U-Substitution. So u is equal to x plus 2, and then du is going to be 1 dx, and so basically du is equal to dx. So now you can do 1 over u squared plus 1 du. And so now you can finally use the inverse trig. So it's going to be tangent. So inverse of tangent of u plus c. And so we need to go back in terms of x. So that was x plus 2 plus c. Thank you for watching this video.